Hello and welcome back to the Master Civil Engineering. In this video, you will learn that how to draw the stress strain curve of a high strength steel and also how to find the yield strength for this high strength steel using the 0.2% offset method. Okay. I have been given a question which states that the data shown in the table we are obtaining from a tensile test of a metal specimen with a diameter of 0.5 inch and gauge length, that is a length over which the elongation is measured, of 2 inches. The specimen was not loaded to failure. We have to generate a table of stress and strain values, plot these values and draw a best fit line to obtain a stress strain curve. Use the slope of the best fit line to estimate the modulus of elasticity. Also, we have to estimate the value of proportional limit and use the 0.2% offset method to determine the yield strength. Okay, our load values, these are in kips, and our elongation, this is in inches. You can see for a load of 0, elongation is 0, load of 1 kips, elongation is 0.001 inch, and so on for the rest of the load values. Our diameter of specimen is 0.5 inch and the gauge length, okay, this is 2 inch. First, we will find the stress and strain values for this test specimen. Okay, so you will make a table in Excel having 4 columns. The first one is the load, then elongation, load values in kips, elongation in inch, then strain, okay, and then stress will be measured in KSI. Okay, so load, for our load value of this 0, elongation is 0. So for the first value of this elongation, strain, this will be equal to elongation divided by the length of the specimen. Okay, so select the elongation value for the first load value, then divide it by the length of the specimen, which is 2 inch. So divide it by 2 and press enter. So this is the strain. So 0 divided by 2, this will be 0. Okay, so then to find the strain for the next elongation, that is 0.0010 divided by 2, and you will get the strain for this. Okay, so simply select the strain for the first load value and then drag it till the last row. Okay, and Excel will automatically give us the value of a strain for the rest of the values. Similarly, stress. Okay, so stress values, this is load divided by the cross sectional area. So load for 0 kips, this is 0 divided by the cross sectional area, that is pi d square divided by 4, or 0.785 d square. So divide it by 0.785, and the cross sectional area of the cross sectional diameter of this specimen, this is 0.5 inch. Okay, take its square, close the bracket and press enter. Okay, this will be the stress. Obviously for load of 0 kips, stress will be 0 KSI, but for a load of 1 kips, you have to divide 1 divided by 0.785 into 0.5 inch whole square. This will give the stress. So simply select the, because we have put in the formula for the first stress value, then select the first stress value and drag it till the last row, and Excel will automatically give you the value for the rest of the load values. Okay, so you can see this one, this is equal to 1 divided by 0.785 into 0.5 whole square. Okay, so this way you will get the stress and strain values, okay, for this test data. Now we will plot the stress strain curve. Okay, so to plot the stress strain curve, we will select this data. Okay, select this data. Okay, and then go to the inserts and then select the charts and select the first one, that is the scatter. Okay, increase the size of the chart. Okay, delete this chart title, add the axis titles. Okay, so for horizontal axis you will write the strain. Okay, and for the vertical axis you will write stress. This value is ksi, that is kips per square inch. Okay. And then you will since we have to plot the best fit line across these points. Okay, so what we will do, we will plot a trend line through these points from the Excel. Okay, so select the trend line. Okay, and then go to these more options and go to this axis option, and let us select our trend line as polynomial. Okay, delete this linear one. Okay, so you can see this trend line approximately fits through all these points. Okay, select the vertical axis. Okay, and take the minimum as 0. Okay, so this is our stress strain curve for this test specimen. Okay, then we will make some modifications to the chart to find the proportional limit, yield strength, okay, and modulus of elasticity. We already have selected the vertical axis. Let us make the tick marks visible for the major type as cross, minor type as inside. Okay, in axis options, change the color from gray to black to make the values more clearly visible and increase the thickness to 1 point. Similarly, for the horizontal axis, change the color from gray to black and increase the thickness to 1 point. And in the axis option, you will make the tick marks visible for major as cross and minor as inside. Okay, also you can increase the thickness of this trend line, so change its color to black and increase its thickness. Okay, so this is our stress strain curve for the test specimen. Now first we will find the proportional limit. Okay, so you can see from the graph that this curve, that the initial straight portion, okay, if I draw a line, okay, so approximately up to this point the stress strain curve is linear or straight. Okay, so this point will give us the proportional limit, okay, up to which the stress is proportional to the strain. Okay, so approximately up to this point, okay, that is up to the stress value of 38 ksi, this stress strain curve is linear. Okay, so for the stress of 38 ksi, draw a horizontal line. This will cut the curve at some point. From that point, draw a vertical line. Okay, so strain for this value, that is the proportional limit, this is 0.0028. okay, approximately 0.0028. okay, so our proportional limit, this is up to which the stress is proportional to the strain. This is 38 ksi, and strain at proportional limit, this is 0.0028. so modulus of elasticity, this will be equal to the ratio of stress by strain. So stress, this is proportional limit is 38 ksi, and strain at this is 0.0028. Press enter and you will get the modulus of elasticity, okay, at this point. So modulus of elasticity, if I decrease the decimal, this is approximately 1357 ksi. Okay, this is the modulus of elasticity. Proportional limit, we already determined it to be 38 ksi. Okay, now to find the yield strength, okay, to find the yield strength, you will use the 0.2% offset method. That is, at the strain of 0.002, you will draw a line parallel to the initial straight line of the stress strain curve, and wherever this line cuts the vertical axis, sorry, cuts the stress strain curve, from this you will draw a horizontal line, and this horizontal line where it touches the vertical axis will give you the yield strength. Okay, so at the strain of 0.002 you will draw a you will draw a line which is parallel to the initial straight line. Okay, okay, you can see this line and this line, which is the initial straight line of the stress strain curve. These are approximately parallel. Okay, so this line, that is the line at the 0.002 value of strain, this cuts the stress strain curve at some point. From this point you will draw a horizontal line. Okay, so draw a horizontal line from this point, and wherever it touches this vertical axis will give you the value of the yield strength. So approximately yield strength, this is between this is approximately 60 ksi. Okay, approximately you can take it as 60 ksi. Okay, or 61 ksi. Okay, let us take is 60 ksi. So we can say that the value of our yield strength, this is 60 ksi, or you can take it conservatively, you can take it 61 ksi also. Okay, it's between 60 and 61 ksi, so let us take it as 60 ksi on the lower side. So our yield strength is 60 ksi. Okay, so we learned that how to find the modulus of elasticity. Simply you have to find the slope of the initial straight line of the stress strain curve. Okay, this will be the modulus of elasticity. Proportional limit. Okay, this is the end point. Okay, end point of the initial straight line portion of the stress strain curve. Okay, and yield strength, you have to draw a line parallel to the initial straight line of the stress strain curve at an strain value of 0.002. Okay, and this will give you the yield strength of this steel. Okay, so this is how you can calculate the value of modulus of elasticity, proportional limit, and yield strength for the high strength steel. I hope this solution video was clear and effective, and you definitely learned something new. If you still have some doubts, you can write them in the comment box. I will be happy to answer this. Thanks for watching Master Civil Engineering, and stay tuned.